Hello everyone, very good morning all of you. How are you all? Good morning and welcome to Unify Study. I hope you all are doing good and all are happy. Start your day happily and start your day with learning. Yes, all are excited to learn the next topic. Yes, I can see all are present here. Everyone is present here. Kirtana, Swapna, Ratna Banerjee, Deepa, Satya, Muthali, Muthamil, Minachi, Usha, Anitha, Sri Ramaya, Vavani, Lalit Mohan, Krishna Devi, Ishwari, Praveena, then Bhuven, अच्छा Ishwari only, Tamil, Ammu, Jyotsna, Rajnikant, Madhumita, Maris, Mallu, then Parkavi, Anu, Swarnalipsha, AJB, Vanja, Vishwapriya, Denke. Is it your original name? Sometimes some different is coming. Is this your original name? Hari Krishna, Divya, Revati, Nesha, Gandhimati, then Chandrika, Rajlakshmi, Kuntal, NK, Vijayarani, SHR, Sapna, Kaveri, Kishore, Saranya, Murshida, Subbu, then Bhargavi, Abhirami, Soja, Joy, Monisha, Lakshmi, Brahma Mohan, Sophie, Krishti, Amar, Megha, all are welcome. Everyone, very good morning and welcome to Unify Study. Yes, so here it's graph theory going on. Yesterday we did the spanning tree, right? Yesterday our spanning tree topic is done. So I will start, as I told that yes, before starting the concept I am going to ask you a question, that is always, let me search any spanning tree for you. Yes, no, this is not. I want to ask you, I gave you some home task also and I hope you did those home tasks. I hope you did those home tasks, but I want to ask you a question. Just wait 1 minute. There was a question But where it is? Just now I saw the question. Tomorrow we will do the practice. I will do the sorting from here, some of the question. Then tomorrow we will do the graph theory practice. After that I will start the next topic. That will be better. Okay, tomorrow let me sort out because there are so many questions, so I am not able to find out now. So tomorrow we will do the practice of graph theory question, then only we can move ahead. Okay, so here the graph theory, these are the topics we did already and questions also done from the spanning tree. Whatever question I provide you, I hope that you already do. Now Dijkstra path algorithm I will go next, because these algorithms are related with your algorithm concept. Here not only Dijkstra, there are 3 algorithm actually we have to learn. That 3 algorithm we will learn at the time of doing algorithm, because here the complexity analysis and all that will be also required, because graph theory is the related topic of data structure and algorithm. So some of the topic we will do in the algorithm part, so that will be more good. Here complexity analysis is required. Okay, so now let's go to the different types of graph that I told today. Different types of graph. Within that, first topic is the bipartite graph. Bipartite graph, what is bipartite graph, and from here the graph coloring concept will also come. So bipartite graph means when you are answer of the home task, answer for the home task. Acha, home task answer, right? Home task answer. Which was the home task? This one to we did yesterday, this one also we did. For this one was the home task, and answer of the home task is this one. This is the home task answer. Okay, that was the home task for you, right? Okay, this Kruskal algorithm you have to do, and which one is the correct order as per the Kruskal algorithm. So answer will be this one, because Kruskal algorithm minimum spanning tree we have to go for the age. Here it is not given anything, although question is appropriate, question is incomplete, but what I can suggest, whenever the incomplete one is there, then you can proceed with the maximum one. You can take with a maximum one like 10 or something, and most correct order according to the question will be, although this question was dropped, but from this question your concept will be clear. You can see GC is 2 and AD is 2. So either you can start with AD or you can start with GC. There is no other option. So here it is starting with AD, here it is starting with GC, AD. If you are starting with AD, then next one should be GC. If you are starting with GC, then next one should be AD. That is confirmed. Here you can see AE, how it is possible. Here you can see GB, how it is possible. Here you can see AG, how it is possible. So just by looking on this one and this one only, you can choose the answer. Within 30 seconds, you can choose the correct answer. No need to do any other thing. Just by looking this, you can see this is the most appropriate answer. Other than that, everyone will be wrong. And that's why your answer will be definitely this one. Definitely this one is the correct answer. Got it? So at the time of solving question, you have to apply the short trick. Blindly don't try to follow. Blindly you will start, and after that you will give the answer. You will waste your 2 minute 3 minute time. No. Always try to apply the trick. How quickly I can solve. Check the first one, check the option, try to eliminate the option, and then go ahead. That is the short trick you can apply. Yes, clear? Clear? This is the answer. This was your home task, and this is so we did yesterday only, right? And other than that, I told you to do this in prims also. So prims, there will be, you have to do the prims as per your way. These are also, you can check with your prims, that is as per your way. So it will be ultimately spanning tree, whatever answer will come, that will be same. If you are adding total, then answer will be always same, total weight, because whatever spanning tree you are doing, the total weight of the spanning tree will be always same. Okay, clear? Clear? This is clear to everyone? Yes. So now let's go to the next topic. The next topic is, as I told, the bipartite graph, isomorphic graph, planar graph, different types of graph we are going to do today. So bipartite, with the name only you can understand, this is divided, the vertices can be divided into two disjoint and independent set. Okay, so you are dividing them into two independent set. How it is? Here you can see another thing, that every edge connect a vertex in U to 1V. Vertex set U and V are usually called the part of the graph. Okay, here with this example you can see, this is the example. In this example you can see this red color, all the nodes are not connected with each other. Even also the blue color are not connected with each other. They are, all the blue color are connected with red color, all the red color are connected with blue color, but there are no connection between them. That's why it is called bipartite graph. Got it? Between them means here to here there should not be any edge, here to here there should not be any edge. That is called a bipartite graph. Okay, this is the bipartite graph. That's why come to the definition. As per the definition, what it is, vertices can be divided into two disjoint set and independent set such that every edge connect the vertex U and V, and there will be no connection. Next one is, you can see that in a bipartite graph does not contain any odd length cycle. It's not containing, this does not contain any odd length cycle. Why? Because you can see, to odd length cycle means what? I have to create like this 3. It is a odd length cycle. That will be not possible. If you are taking this small one as a bipartite graph, you are taking this small one. So if I am trying to make a cycle, how I can make the cycle here? This one will be connected. After that, this one will be connected with this one, then this one, then this one. This is the way only I can create a cycle. So what is the length of the cycle? Length of the cycle means to come back. What is cycle? Cycle means it is my starting point. To come back to my starting point, how many edges are required? That is called cycle. Okay, so here how many edges are required? That is 4. So cycle of an graph, that is a bipartite graph, will be always even. Can you make a cycle like that? This one, that is a triangle type cycle. It's not possible, because this one and this one will be not connected. This one and this one will be also not connected. That's why this is a very important theorem. Okay, you have to remember all the theorem, because theoretical questions are coming from theorem. We will practice. Tomorrow I will allocate the day only for practice question, practice MCQ and PYQs of graph theory. All the graph theory question we will do practice tomorrow. Okay, so learn the concept so that tomorrow we can dedicate for MCQ practice. Is this clear? Why it is even? Why it is not odd length? Is this clear to everyone? So U and V and may not be as coloring graph with two color. Always there will be two color. Why two color? What is the coloring concept? Graph coloring concept is that any adjacent, you learn the adjacent, okay. Repeat once again about cycle. The odd length cycle is not possible. Odd length cycle is not possible. Sapna, just now I told that. This example, check this example. You will be not able to create a cycle of length 3. Here you will be not able to create a cycle of length 3. Wherever you are starting, you want to come back to that. So that's why you cannot create. Cycle means how many edges are required to come back to my starting point. So to come back to my starting point, this is the way only I can create a cycle. And the cycle length will be 4 here. So always cycle length will be here. Even cycle length cannot be odd in a bipartite graph. Write down in your notebook. These theorems are very important. Theoretical questions will come from here. This is the first theorem. The second theorem is what? Is this clear? Is this clear to everyone? The second theorem is that it will be two colorable. Always it will be two colorable. Two colorable means what? Coloring concept is that whenever two adjacent node, okay, whenever two adjacent node means what? They are connected, this one and this one. If they are connected with a edge, they are connected with an edge, then you cannot use same color between them. Then you cannot use the same color of both node. You have to use different color. Whenever they are connected, then you have to use different color. Adjacent vertices should not be of same color. Adjacent edges also should not be of same color. If you are drawing an edge here, that will be also different color, because here I use green color, here I have to use red color, because they are adjacent edge. First class we learned what is called adjacent vertices and adjacent edge. This is the concept of graph coloring. So here we need two color, exactly two color. Why? Because you can see anyhow this set will be not connected with each other. That's why I can use the red color for this. And anyhow this one will be not connected with each other. That's why we can use the different any other color. It's not mandatory red and blue, any other color you can use. And that's why bipartite graph is always two colorable. I am telling you have to write it. Note down these points in your notebook. Very important. They are asking statement type question. You have to be ready for that. So what are the two algorithm? First two algorithm you understand? Yes. What I told, this is clear to everyone? Yes, so this is the theorem. Here the graph is bipartite if and only if its cycle has even order. That is the one theorem. And here another one is the two colorable. I hope it is clear to everyone. Right? Yes. So regarding spanning tree, here is a question on spanning tree. You can try this spanning tree question. I hope you will be able to do it. Cycle length always even and it's two colorable. Yes, bipartite graph will be always two colorable. Okay, tell me one thing before coming to this. If I am drawing a graph like this, I am using one color only. You have to think That is it a bipartite graph? Is this a bipartite graph? Is this a bipartite graph? Tell me the answer. Is this a bipartite graph? If I am drawing this graph, I use one color only for drawing. It is your question. So you have to think, is this a bipartite graph? Everyone is telling no, 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 no. Pakka. Sure. Sure, it is not a bipartite graph. Acha, you are telling it's not a bipartite graph. So I am giving the number here, okay? A, B, C, D. This graph itself, can I draw in this way? A is here. This is A. A is connected with B. So A is connected with B means B will be in different set. So A is connected with B, and there I have to use a different color, because as they are connected I have to use a different color, that is B. Now A is connected with C, that's why I have to take a another one that is connected with C. So A is connected with C also, right? Now where is D? D is not connected with A. D is not at all connected with A. So I can put D here. D can be in same set of A because D is not connected. D is connected with B. D is connected with B. And D is connected with C. The same graph can I draw in this way or not? See that actually they are same graph. Understand this concept. Graph means not the shape. Graph means not the shape. Graph means the connection. Forget about from your mind. Graph means not the shape. Graph is the connection between vertices and edges. A graph I can represent in different way. A same graph we can represent in different way, and that is called isomorphic graph. This is called the isomorphic graph, and that is the concept of isomorphism. We are always thinking about shape. Shape is not the factor. Factor is the properties of the graph. They are connected, adjacency, degree. All these are the main properties. So by looking the graph, don't take the decision. Try to convert it. Try to think it. Can I represent in different way? Is it possible to represent in different way? If I am able to, whenever they all are not connected, always remember, whenever they all are not connected between each other, then we can create a bipartite graph. If the graph is not a complete graph, then definitely it can be bipartite graph. Got it? Clear? Yes. So everyone was telling that it's no, 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 but I am telling it's yes. This is a bipartite graph. Is this clear? How to make bipartite graph? Yes. I hope it's clear to everyone. Right. Good morning. Now you are joining. So many students are joining now. So why you are late? Why you are late? Got it? The concept is clear to everyone. The concept clear to everyone. Yes, very good. Acha, now tell me one thing. Acha, here only I am drawing. Is this bipartite graph? Is this a bipartite graph? Is this a bipartite graph? Is this a bipartite graph? Yes, this is not a bipartite. Now you are telling yes. Anna Durai. You are telling yes. Yes, how it is. See that it is a complete graph. Okay, it is, you cannot make them separate. Anyhow, you cannot make them separate. Ammu, try to think logically. To make a bipartite graph, I need to make them separate. It is a complete graph. Everyone is connected with n minus 1 vertices, right? Everyone degree is 2, 2, 2 here. Everyone is connected. You cannot make them with two color, because everyone is connected between each other. If you are making here blue color, then you have to use the red color here, and here you have to use a different color, that is green color. You cannot make them separate into two set. You are not able to make them separate into two set, and that's why it is not a bipartite graph. Got it? Is this clear? Achha, tell me, is this a bipartite graph? Is this a bipartite graph? Is this a bipartite graph? Now no, yes, no, yes, no, yes, no, yes. So many answers are coming. Achha, first of all, now I am getting so many answers are coming. No, yes, no, yes. If I am asking, is it a complete graph? First of all, keep it in your mind. To think about bipartite graph, first of all, I have to think, can I make them separate? You are focusing on cycle. Forget about cycle. Yes, cycle you can think. First of all, you can ask yourself, can I make them separate in two set? Is it like that they are connected, all are connected? Is it a complete graph? Is this a complete graph? Is this a complete graph? Complete graph means everyone should be connected with each other. This is not a complete graph, right? This is A, this is B, this is C, this is D, and this is E. Is this a complete graph? You can see B and E are not connected. Who are connected? Here A, B, C, A is connected with B, A is connected with C also. They are connected with each other, right? Yes, yes, right. But A is connected with E. Is this A is connected with E? A is not connected with E. A is not at all connected with E. So I can do E here. That is E. A is not connected with E. Even also B is also not connected with E. Right? A is also not connected with E. B is also not connected with E. Right? Yes. C and D is connected with E. Yes. So here A, B, C. A, B, C, they are connected with each other. So I can do like this. Wait. I can do like this. We have to think here. A and E. I can put in same set. Because A and E are not at all connected. So I can use the same color. A and E anyhow not at all connected. That's why I can use the same color of A and E. And now you can see the A and C is connected. A and B is connected. Yes. I am not doing edge color, I am doing only vertex color. Okay. So A and C is connected, A and B is connected, right? Now B and D is connected. So as B and D, can you make them separate? A, C, I make them separate. So A and C are connected, that's why. A and B are connected, that's why I can make them separate. Yes. Yes. Yes or no? Now D. What about D? Where I should put D? What about D? Where I should put D? D should be in red color or green color? D should be in red color or green color. D is not connected with C, but D is connected with B. Yes. D is not connected with C, but D is connected with B. Yes. So can you make them separate? Are you able to make them separate? If there are 4, then I can. Green color. D, what we will do with D? D is red. If I am doing D red, then D is connected with B. If I am making D red, then it will violet because D is connected with B. That will be not. If I am giving D here, that is in green color. D here. A is not connected with D. D is connected with E. Then also it will violet. Right? Yes. So you are not able to make them separate. Because if you are using, now think about color. As I use here green color, that's why the connected one, what are not connected, A is not connected with that, so I can use the green color here. A is not connected with DE, that is okay, right? But A is connected with B. So here I can use red color. A is connected with C. Here I can use red color. Yes. So C and B is red color. Yes. Can I do it? Now that is okay. two sets. This is see that A is not connected with D, A is not connected with E. That's why I use the DN color. But here D and E is violating the rule because D and E is connected here. So here any one of them I have to change. D and E are connected. That's why I cannot use the same color here. I have to use a different color, like maybe blue color. Yes or no? Anyhow, you will be not able to make them with two color. You have to use the three color here. Anyhow, you are not able to make them separate. You have to use three color here. And that's why you cannot make them separate. And that's why, is it bipartite or not? Now think. Yes, no, so many answers was coming. Now tell me, is it bipartite or not? Yes. Two color, can you make two color? Are you able to make two color here? You will be not able to make here two color, see. Anyhow, you will be not able to make them two color. Whenever you are coloring, adjacent should not be of same color. Adjacent should not be of same color. Adjacent you cannot make same color. Yes, so it is not bipartite. You are not able to make them separate. Anyhow, you will be not able to make them separate. Yes, clear. Concept clear. Concept clear. So this is the way you have to think. How to think. Understand how to think. Okay. Yes. Thinking process is very, very important. Thinking process is very, very important. BE in red color and ACD in green color. BE in red color and ACD. ACD, how you are able to make? No, A is connected with C but A is not connected with D. If you are able to make, tell me. Anyhow, BE in red color, B and E in red color. Acha, let me try. If you are able to make it, then let me try. You are telling here B and E in red color. Make it B. So I am taking red color. BE red color and ACD green color. A C D, you are telling that green color. Okay, so between A to C though there is connection. Between A to C though there is connection, it is violating rule. Is it or not? Can you use same color? Between A and C there is connection. Whenever there is connection between them, then you cannot put them in same color. It is not possible. You cannot put them in same color. It's not possible. Got it? Clear? Yes. AC are connected. Anyhow, you can think, you will be not able to do. C is connected. Got it? Clear? Clear? Yes. So you have to explore. Subject is not subject knowledge. Computer science is an interesting subject. Computer science, try to play with a game. Try to think it is a game. It's not like that you are learning it to means forcefully. No need to learn. It's a game. It's a game. You have to think like that. It's a game. Okay. Okay. Clear. Clear to everyone. Okay. Chalo. Odd length cycle may ma'am not be. See that here, or it cannot be. It is cannot be even length. That means that you will check only odd. No. That's why I am telling. If you are focusing only odd length, then you cannot take the answer. You have to think about the bipartite means the first property of bipartite is can I make cycle always even order. You have to think about that. Theorem is not telling you odd. It is telling you the graph of bipartite if and only if it has even order. So if it is even order, then only it is possible. That does not mean that if odd, then always it will be. It may be, it may not be. Okay, the vice versa, it's also not always true. If it is even order, then only it can be. And not only that, other than that, you have to think. See that here it is a even order, you can make it. Okay, clear? Yes. Odd length cycle, how ma'am, may not be bipartite. Yes, this is bipartite. Definitely this is not a bipartite, because it is the odd length. Here definitely as per the odd length you can think. You can think, but concept should be clear. Okay, clear? Yes. So now see that this question, try to see. So you can convert a graph in different way. That is the isomorphic property. We will learn the isomorphic property, and I think the graph coloring concept is also clear to you. Wow, how to do the graph coloring. So now see that what will be the answer of this question. The number of spanning tree in a complete graph K4 are bipartite graph K22. Odd length cycle, yes, this is a odd length cycle. Definitely this is a odd length cycle, and that's why this is not bipartite. That's why this is not bipartite. Someone was telling that it is bipartite, and I prove in front of you it is not bipartite. Okay, definitely odd length is not bipartite. Number of edges. Cycle length means the cycle length is number of edges in the cycle. That is called the odd length. Number of edges. How many edges are there in the cycle? 1, 2, 3, 4, 5. So here length of the cycle is 5, and that is odd. Length of the cycle is 5, that is odd, and that is not possible here. Okay, yes. So here you can see, yes, the answer will be what? Answer will be here 16 and 4. Option C is the correct answer. This is another theorem. Total number of spanning tree in a graph, in a complete graph, will be n to the power n minus 2. That is yesterday we learned. And for a bipartite graph, how many spanning trees are possible? Bipartite graph we are representing like this way, KNM. Okay, KNM means, what is the meaning of KN comma M? The meaning of that, if I am writing K2 comma 3, K2 comma 3 if I am writing, means one side there are 2 vertices, and another side there are 3 vertices. That is the meaning. Okay, this is the meaning of the representation. Now it may be complete, it may not be complete. If I am doing like that, they are connected between this, and this is connected with this. Okay, it is not a complete one. This is not a complete bipartite graph, but it is a bipartite graph. What is the difference between complete bipartite graph and normal, means any bipartite graph? When each and every node of a set is connected with all the node of another set. Like here, if it is connected with this one also, and if it is connected with this one also, if it is connected with this one also, then only this is complete bipartite graph. Complete means one set will be connected with other set completely. Completely they are connected, then only it is complete bipartite. Otherwise, if some of them are connected, some of them are not connected, then that is not a complete bipartite graph. So number of spanning tree in a complete bipartite graph is Kmn equals to n to the power m minus 1 and m to the power n minus 1. M to the power n minus 1 and n to the power m minus 1, that is the answer. So here you can see, as it was K4, according to this formula, K4, what is the meaning of K4? This is also very important. Always remember, Kn is the representation of complete graph with n vertices. This is the definition. Kn, sometimes it can be given in Kn. So Kn is the complete graph with n vertices. So K4 means n equals to 4. 4 to the power 4 minus 2, that is 4 square. 4 to the power 4 minus 2, that is 4 square. So it is 16. This is 16, okay. And here what it will be? Here whenever you are doing this one, that is nm. So it was 2. In the question it was what? 2. So it will be 2 to the power 2 minus 1 and again 2 to the power 2 minus 1, that is actually coming 4. Okay. So that's why your answer will be here 16 and 4. Okay. Here now I am want to say that what is the difference between complete graph and regular graph? Do you know? Do you know that? What is the difference between complete graph and regular graph? These are the two types of graph. Complete graph, if I am writing Kn, this is the representation of complete graph, and I can write it K regular graph. Okay, K regular graph. Complete graph is Kn and K regular graph. We are writing like that, regular graph. So what is the meaning of regular graph and complete graph? What is the difference? What is the difference? If it is written like that, K4, and if it is written like that 4 regular graph, what is the difference between them? So understand the difference between them. Difference between them is complete graph means here the K4 will be looks like this. It is looking like this. Complete graph means 4 is representing the number of vertices. Here the n is representing number of vertices. I have 4 vertices. And complete means everyone will be connected. Yes. So here what it is? So everyone will be connected here. Everyone is connected here. That's why it is called the K4. Okay. And this one only, this is it 4 regular graph? No. This is a 3 regular graph. This same graph is actually a 3 regular graph. Why it is the 3 regular graph? The regular graph means, what is the meaning of regular graph? The regular graph means degree of all vertices are same. Degree of all vertices are same. That is called regular graph. And here degree is 3, here also degree is 3, here also degree is 3, here also degree is 3. That's why this is a 3 regular graph. This is a 3 regular graph, but this is K4. K4 means complete graph with 4 vertices, but it is a 3 regular graph. And another difference between regular graph may not be connected. Regular graph may not be connected also. Regular graph may not be connected, but complete graph will be always connected. This will be always connected. Write down it in your notebook. These are the different graph are very important. Okay, clear? Is vertex of degree 3? How 4 is possible? It's not 4, it is a 3 regular graph. It's not a 4. That is I told. Here it is 3 regular graph and this is K4. K4 means here it is representing how many vertices are there. And complete graph will be always connected, but it may not be. Clear? Is this clear to everyone? Is this clear to everyone? Yes or no? Is this clear? So if I am asking you this one, can you tell me what is this? If I am asking you this is a graph, you have to tell me what should be the name of the graph as per complete and as per regular. Is this a complete graph? Is this a complete graph? If it is complete graph, then what should be the mathematical representation? And is this a regular graph? Is this a regular graph? If it is regular, then what should be the mathematical representation? What should be the mathematical representation? K2 and 2 regular, is it? Is it K2? It's not K2. Who is telling that? Deepa. Is it K2? It is not K2. It is not 2K. It is not K2. It is not K2. It is not K2. Those who are telling it's K2, they are wrong. They are wrong. K end means the end should represent the number of vertices here. This is number of vertices. It's not K2. It's not at all K2. It's a K3. K3. How many vertices are there? 3 vertices are there and it is a complete graph. And what are the degree? Everyone have degree 2. That's why this is 2 regular graph. That's why this is 2 regular graph. Yes. Got it? You have to think like this. That is a 2 regular graph. Okay. Acha, is this a complete graph? This one, if I am drawing this one is not a complete graph. This is not a complete graph, right? But this is also a 2 regular graph. This is also a 2 regular graph, is it or not? Because here also degree 2, here also degree 2, here also degree 2, here also degree 2. This is not complete, but this is 2 regular graph. Okay, clear? Clear? Okay. I said, now tell me. Is this a regular graph? Is this a regular graph? Is this a complete graph? This graph is a complete graph. Vendra, every complete graph is regular. Every complete graph is regular graph, but vice versa is not true. That is okay. That is correct, because every complete graph there will be n minus 1. K3. Complete K3, K2. Not complete, it's not. Is it a regular? I am asking, is it a regular graph? Is it a regular graph? Yes. This is not a complete graph. This is not complete. But this is regular graph. Yes, this is regular graph, because everyone have degree 2. Everyone have degree 2, right? So this is a 2 regular graph. So from here only you can understand that regular graph can be disconnected also. Regular graph can be disconnected also. Yes, regular graph can be disconnected also. This is a very, very important point. Complete graph is not disconnected. Complete graph is not disconnected, but regular graph is disconnected also. Okay, ठीक है? Clear? Yes. When I am discussing concept, then you are asking for PDF. So tell me, if I am giving this PDF, through the PDF, can you understand anything? Tell me. This is completely concept I am discussing of graph theory. So what PDF you want for that? This is so you have to write down, you have to draw. Right? This graph theory, what PDF you want? This graph theory, what PDF I will give you? You can buy a graph theory book also, but also you will be not able to understand anything. I request everyone and I suggest everyone, definitely where the PDF is required, theoretical concept, the software engineering PDF I provide the software engineering PDF, right? Where PDF is required, question, PYQs, other theoretical concept, where actually PDF is required, definitely I will provide you PDF. But for this graphical concept, what you will do with PDF? You have to draw, you have to write, you have to understand. If I am giving you all PDF also, you will be not able to understand anything. Try to think. PDF, don't shout like anything. Start writing in your notebook. PDF I will provide. Start writing in your notebook. What you will do with this PDF? Why you guys are not able to understand? I will provide you whatever important PYQs, so many PDF, concept wise where required. Yesterday I upload the software engineering PDF. When concept is going on, you are not focusing on concept, you are focusing on PDF. What you will do with PDF, I am telling you. You will collect so many PDF. You will took the printout also so many PDF. But you are not going to learn that. I am giving you guarantee. If you are collecting lots of PDF, you will take printout also, but you are not going to learn from that PDF. I am sure about that. I am sure. Those people, those who are very much interested about PDF, please start writing. Start writing. In my class, it is a thumb rule. I will request you, I will suggest you, try to focus on your own writing, on your own thing. Okay, I will provide you PDF. Okay, ठीक है. PDF foundation learning तो that I provide. Foundation learning, graph theory, basic terminology, where required, where the PDF will be required, definitely I will provide. Okay, where the PDF is required, I am providing that. Foundation, terminology, I provide. Here we are discussing the concept. Here what you will do with the PDF, tell me. Yesterday also some students was asking me, some of the points are there, what is this graph, what is that graph, how to draw and all. This much also you are not able to write. This much also if you are not able to write, then leave your learning. No need to do learning, do any other thing. Please. Okay. ठीक है. 10 subject, 10 notes. Yes. So please leave your learning. I will give you PDF definitely, but no need to ask me where the PDF is required, where the PDF is not required. I know that where PDF is required, where PDF is not required. If you want to get success, let me show you. Can you see my bed? Can you see my bed? Just see that. I want to show. See this, see. Just see. This is my bed. Are you able to see my bed? Just see. What you have to do, I hope you are able to understand. I hope you are able to understand. Okay. So these are ultimate source of my knowledge. These are ultimate. Here I am teaching and here are all the collection. Okay. So this is my bed. This is my bed. This is my bed actually. Okay. Okay, so yes, I read all this book. I read all this book. All this book. Every lines, every page is known to me. All these pages are known to me. Okay. All the pages are known to me. Okay, so every subject, how many books I have, you can see. There are more books in my wardrobe. There are more goods. There are more books in my wardrobe. Whatever now required, it is there. Till now, so many books what I read from library, that is not there. Okay, so you have to understand the source of knowledge and the concept. Okay, the source of the I will provide, and I know that this much book you cannot read now. You cannot read now. Okay, this much book it is not possible to read by you. So I am telling you, I am learning book, I am giving you concept. Focus on concept. PDF I will provide, don't worry. Okay, so don't worry about PDF, I will provide you. Please focus on concept. ठीक है? Okay, so here just I show here what is the thing going on. Okay, chalo. So I hope you can understand. Okay. Yes. I will provide. See that notes I will provide. Don't worry about notes. I will provide the notes. I will provide the notes. Okay, but no need to tell me again and again. I will provide. Don't worry about that. Wherever it's required, I will provide you. And so now we will learn the isomorphic graph. What is isomorphic graph and what are the property of isomorphic graph? Okay, what are the property of isomorphic graph? Okay, so yes, I am cool, just I am trying to say that don't go for shortcut. Shortcut is not giving you success. Focus on concept, read books also, understand concept also. PDF I will provide, don't worry, okay, ठीक है. No need to ask me again and again for PDF. Whatever required I will provide. Focus on your concept. Chalo. Isomorphic graph. What is isomorphic graph? Two graphs are said to be isomorphic. Just now we draw a isomorphic graph. That is this one. Right? Two graphs are said to be isomorphic. Here is the graph. Okay. So here whenever the graph is there, we draw like this way. We draw this graph like this way also. Means a same graph you can represent in different way. The same graph you can represent in different way also. Yes. ठीक है. So the same graph if you are representing in different way, that is called isomorphic graph. So the graph said to be isomorphic if they are same graph, just draw the differently and different name also. You are drawing it different way with different name. So what are the properties you have to think about? That is adjacency, number of vertices, degree of each vertices, minimum and maximum cycle of length, connected, disconnected, planar, non-planar, edge connectivity and vertex connectivity. These are the main concept to focus on the isomorphic graph. Here just an example I took. You can see that how to check the isomorphic, is they are isomorphic or not. This graph and this graph. Okay, they are isomorphic or not. We have to check first of all number of vertices, number of edges, the cycle, they are correct or not. Then you can make them. You can see this one. I think you are not able to see. You can see this one here. A you can relate with 1. A you can relate with 1. Why? Because A is of degree 3, 1 is also degree 3. A is connected with B of degree 2. A1 is connected with 4 of degree 2. A is connected with E, that is of degree 3. This is also of degree 3. It is connected with another one of degree 2. Here also it is connected with another one of degree 2. In this way you have to check what are the, how I can make them connection. How I can make them connection. So A will be related with 1, B will be related with 3, C will be related with 2, D will be related with 4. According to the degree, adjacency, everything. And the edges you can relate, x1 is with y1, y3. x1 will be with y3, that one, this one. So this is called isomorphism. This is called isomorphism. Okay. Okay, this is called isomorphism when we will able to provide like that. Isomorphism means just you have to relate to what? Two graph. You have to relate two graph that first of all focus on the number of vertex. Is the number of vertex are same? Then focus on number of edges. Then try to check how many vertex of degree 1, how many vertex of degree 2, how many vertex of degree 3. Is it same here also? then check the adjacency, that yes, this is a vertex of degree 3, this is connected with a vertex of degree 2, it is connected with a vertex of degree 3, it is connected with a vertex of degree 2. Can I relate them? Am I able to relate them? If I am able to relate them, then they are isomorphic, otherwise not. Another way is there the cycle also you can check. How many cycles they are? There is a cycle of length 3. Here also the cycle of length 3. Here another cycle of length 3. Here also another cycle of length 3. Okay. So this is the main property: adjacency, number of vertices, degree of each vertices, minimum length cycle, maximum length cycle, connected, disconnected, planar or non-planar. I am coming with that. What is planar, what is non-planar, and edge connectivity and vertex connectivity. This is, you have to experiment. Here your experiment is required. Am I able to relate them or not? The experiment is required. Okay. If the experiment is not there, then you cannot do. Here it's your experiment required. ठीक है? Clear? Clear? Yes. Yes, is this clear to everyone? So this is the way. Here you can check. These are your home tasks. That is, you have to explore. You have to explore. These are your home tasks. This one, is it isomorphic or not? This one, is it isomorphic or not? This one, is it isomorphic or not? Till now, whatever property you learn, with that property only you need to relate. They are isomorphic or not. Okay? ठीक है? Clear? Okay. Now see the planar. What is planar graph? Planar graph means, am I able to draw it in a plane? By looking this one, you will see that, you will think that there should not be any intersection between two edges. If there is the intersection between two edges, then that is not planar. Okay. So as you can see, here is a intersection. By looking, you will think that no, it is not planar. But the same one I can draw like this. The same one I can draw like this. So that's why it is not, it is also planar. Right? Clear? Yes. Got it. Here also you can see, this one, so many intersections are there. Here also intersection, here also intersection. So many intersections are there. But these intersections, this intersection, whenever you are trying to draw in different way, this is, you are able to draw. You are not able to, you are, it is, intersection was there, but you are drawing it in different way, so that there is no intersection. Whenever there is no intersection means it is planar. This is very easy. Just I will represent the graph in different way, so that planar means I need to represent the graph in that way, in a plane, so that no intersection between two edges. These intersections are not allowed. These intersections are not allowed. You have to think, without intersection, can I draw it? Can I draw it without intersection? If I am able to draw without intersection, means that is planar. Okay? Clear? Is this clear to everyone? Is this clear to everyone? Clear? Okay. So now you can see here the properties. These are the some properties through which property you can identify. Because in exam they will give you very typical graph, and from that typical graph if you are trying to draw, that will be difficult for you. So that's why we can go for some properties. What are the properties? A connected planar graph with V vertices and E edges, always there will be E minus V plus 2 region. What is the region? You can see. Here region means the covered area. Region you can make a different color. This is one region. And here this is another region, that is of another color. This is of another region here. Okay, and here this one is another region. This is of green color. This is another region. Okay, and outside of this one is another region. This is completely outside. This is completely outside, and that is called the another region. So how many total regions are here? Here how many total are regions? How many total regions are here? There are total, how many color I use? 1, 2, 3, 4. Total 4 regions are there. So now try to verify the vertex and edge also. Try to verify the vertex and edge also. If you are verifying it, how many vertices are there? 1, 2, 3, 4 vertices, right? So B equals to 4. How many edges are there? E, that is 1, 2, 3, 4, 5, 6. 6 edges are there. What was the formula? Formula was E minus V plus 2. That is 6 minus 4 plus 2. That is 4. Is it matching with 4? Is this matching with 4 or not? This is definitely matching with 4. Region means inner region plus outer region. Always remember. Outer region also, that is the yellow color region. That is the outer region. So inner region plus outer region, both you have to calculate. If they are asking only inner region or bounded region, if they are asking only inner region or bounded region, then always remember you have to do E minus B plus 2 minus 1. Okay, inner region or bounded region, or it can be faces region. Write down that. It can be faces region also. Inner, bounded, faces. If they are asking this way, then it will be E minus B plus 2 minus 1. Very careful about that. Questions are coming from here. Very careful about that. Questions are coming from here. Okay. Clear. This is very important. Whenever you are able to count that region, then easily you can say yes, it is planar or not. This is the first property and very important property of a planar graph. Other than that, something K33 is not a complete, it is not a bipartite, it is the complete bipartite graph, and it is not planar. Anytime, whenever you will see in a graph the K33, that is a bipartite graph, it's complete bipartite graph, it's not planar. K5 is also not planar. These are very important. Okay. Another theorem is there, that is called Kuratowski's theorem. A graph G planar if and only if G contain no subgraph of K5 or K33. If you are able to find out any K5 graph, any K33 graph, directly you can say it is not planar. Okay. Other than that, some properties are also there. that is that if G is maximal planar graph, then you can put this one also. If the number of vertices are n greater or equals to 3, then here will be m equals to number of edges will be m minus 3n plus 6. Through this you can satisfy, that is less or equals to. If there are no triangle, then it will be m less or equals to 2n minus 4. How it is? If you can see, this is a graph. There is no triangle. No triangle is here. So how many vertices are there? 2 multiply 4 minus 4. So there are 4. So m means number of edges. M equals to 4. Yes. This is matching, m equals to 4. So this theorem is verified. Yes. If there are no triangle, then you can do. If there are like that n greater or equals to 3, this theorem also you can apply. It is greater or equals to 3. Here you can do 3n minus 6. So 3 multiply 4 minus 6. 3 multiply 4 minus 6. 4 will be less or equals to. So here it is 6. 4 is less or equals to 6. Yes. So always understand and how to verify. Whenever in the question they are given, you will be not able to draw. You cannot draw it. So then you can follow these properties. By following these properties, you can understand, okay, this is the going on here. Clear? Is this clear? Now do this one. Achha, do this one everyone, and I will upload the PDF on Unify Study app. Okay. I scold you very much. I am feeling bad for that. I am so sorry. I am so sorry for that, for scolding too much. But really I want that you should understand it very properly. So you can install this app everyone. I will upload the PDF here in the app. Okay. I will upload this PDF of different type of graph. In here. Okay. So I will upload after the class. Sorry for scolding you too much. Don't take it otherwise, please. Don't take it otherwise. Sorry for scolding. Acha. Now say again. See. Yes. Answers are coming. Now. Let's see what is the correct answer. So many answers are coming. Six, seven. So many answers are coming. 6, 7, 6, 7. So what is the correct? 6 or 7? Just now, that's why I told 6 is the correct answer. What I told, bounded faces region. Bounded faces region means, just now I told you. That's why you have to be very careful. It is a red alert for you, those who are telling 7. AJB, Lakshmi, Srinivasulu, Amar Mani, Prathiva, Sarnalipsha, Geeta, Anu, Kishore, Krishti, Srinivasulu. You told that, but still, see that here this is Manikam and Bitha. All of you are, it is a red alert for you. Be focused in the class. I totally write down the keywords also here. Just now I wrote here the keywords, that faces, inner, bounded, then you have to do E minus B plus 2 minus 1. Because the outer region you have to cut. Inner region plus outer region is this. When they are telling only in a region, then you have to cut the -1. But still you are doing mistake because you are not focusing in the class. Sunday morning I wake up, I came here to teach you, but you are not learning properly. Here it is 15 minus 20 plus 2 minus 1. That's why it will be here. This is 5 plus 2. You are telling 7. 7 is not the answer here. Here you have to do -1 because of these bounded faces. You have to think the keyword bounded faces region, right? Did not read. It is my fault or your fault? If you are not reading, see that I already cracked 2 times, right? So I already cracked UGC NET. I already cracked SET exam also. This year I cracked PhD entrance of Hyderabad also. I cracked PhD entrance exam also, but in interview, anyhow, for PhD proposal I left out, but I was not able to write a PhD proposal properly, but the written exam I qualified. Okay, so if I am attending any other exam, I will be able to qualify, I know that. But what I will do, it's not required for me, right? It's required for you. You need to qualify. So if you need to qualify, then what is required? You need to read question carefully. If you are not reading question carefully, you will miss the marks. Whatever I am teaching in the class, how in depth I am teaching, maybe previously I did not teach in that way more, maybe because of so many constraints, because of lots of constraints. Within 3 months you have to cover the syllabus. Within 5 days you have to cover one total unit. So that type of constraint was there. So I was also bounded like that. If I am trying to teach in depth, then it was required lots of time. Every time I was telling that it's required at least to cover the syllabus at least 6 months or 1 year, a complete thing is there required. But I was not able to get that chance. So that's why I was also little bit hurry. I was trying to do whatever important one that was I was trying to do. But now I am giving you the full in-depth for basic, so that any kid, those who are in the first year of the college, they are also able to understand everything. Is it or not? I am teaching everything very clearly, right? Although I give the name as crash course, but it is not going on as a crash course. It is going on in depth. I am trying to give my 100% so that everyone from basic level also, advanced level also, wherever you are, you can understand that. Still, if you are not taking, it's yours. You will think what you will do, right? Yes. So answer will be 6. Very much careful, okay? Very much careful about that. So graph coloring concept we did. The chromatic number. What is called the chromatic number? Chromatic number means how many color you are using. This is called chromatic number. We discussed the graph coloring. How many color you are using? Minimum number of color. What are the minimum number of color you are using? That is called the chromatic number. Okay. So here you can see how many color we use here. Here is the red color, green color and blue color. With 3 color we are able to use. Always our target will be minimum number of color. How we are able to color it with minimum number. So here the age coloring concept is like that. Here you can see the degree. What is the degree? As per the minimum, whatever, if there are so many ages, then I have to do different color. Then I have to do different color. It's black. I have to take here green. And maybe I have to take here yellow. Right? These are the different color I have to use. That is called age coloring. Vertex coloring is there, age coloring is there, and region coloring is also there. So always the number of color required for the edge coloring will be as per the degree or degree plus 1. What is the degree? Maximum degree or degree plus 1. Okay. Bipartite graph, planar graph, that will be always as per the degree. Whatever degree, maximum degree, that will be. For a multi-graph, it will be 3 delta by 2. So here you can see this is the region color. And it is also concept. Always in a planar graph, it will be 4 color. Any map coloring, if you see any India map anywhere the India map, they are using 4 color. Everywhere, any country, any map, if you are showing, you will see with 4 color only they are coloring the map, right? So any planar graph you can color with the 4 color, that is called the 4 color theorem. Okay, in worst case it will be maximum required 4 color. It is also a checking of the planar graph. Can I do it with 4 color? If I am able to do with 4 color, then it will be planar, otherwise it is not planar. This is also a checking of planar graph. Okay, planar graph will be always 4 color. Region, it's not vertex, it's region. So here you can see the question. What will be the answer then? This is a gate question. You can see the minimum number of color that is sufficient to vertex color any planar graph. So what will be the answer? Today I have extended little bit the class. I hope you are not feeling bored. Today is Sunday, right? So Sunday my daughter's school is not there, so I thought okay, we can extend little bit. Whenever I have time, I am really love to teach. I really love to teach you. Yes, the 4 will be the answer. Yes. So remember that for checking the planar graph, you can check that vertex color. Can I do with 4 color? Can I do with 4 color? Then also it will be the answer. Now tell me, this is also a GATE question. This is also a GATE 2018 question. The chromatic number of the following graph. What is the chromatic number of the following graph? Okay, answers are coming. Yes, here your answer is 3. How to do? Here the trick. Here what is the trick to do the chromatic number? The trick is that find out the maximum degree. Find out the maximum degree and color it. Okay. What is the maximum degree? This one is my maximum degree. I will color it with red color. If I am coloring with red color, which one is not connected with me, I can use the same color. So I am using same color here. This is not connected with me. Now whatever connected with this one, I have to use a different color for that. So I can use a different color here. So as this one is not connected, I can use that different color. Now you can see the 2 more left. So I have to use a color. This color. Yes. I have to use this color. So easily I can do with 3 color, not 4. Minimum. You have to think about minimum. You have to think about minimum. Sikandar, it's not 4, it's 3. It's not 4, it's 3, right? With 3 color only you can do, and that's why answer will be 3, not 4. Clear? Clear to everyone? Yes. So the graph coloring, isomorphic, planar and bipartite. That was the today's target. Planar, bipartite, isomorphic and all. So I hope it is clear to everyone. No one have no doubt. Yes. No one have no doubt. Chalo. PDF I will upload there. You can download the PDF after the class and you will get the notification also. Yes. Acha, tell me. Now as you all are interested for PDF, I am asking you something. So I am asking you openly. Always I believe that the suggestion and feedback from the student is very, very important, and I believe you are my team. So if I am giving you PDF, my PDF is always, you can understand, with a concept question together you can get the PDF. So PDF of every unit wise, if I am giving you the unit wise PDF, what is printable version? It will be printable version that you can download and you can print also. Okay, and I hope you will not cheat with me. It is a request to you that yes, tell me that price so that I have, because as I am investing my PDF, every unit wise PDF is near about 500 pages. Some of the PDF are 800 pages also, because there is concept, and with the concept so many questions are there. Concept wise so many questions are there in my PDF. Okay, so tell me, if it is a printable version, and I hope you will not share with everyone. It is a request to everyone. Why I am not giving PDF? Because if I am giving printable PDF and if you are sharing with everyone, try to think that what will be for me. Okay, so I will request it that try to be little bit ethical. Try to be little bit ethical also. I hope you will not do that. Okay, tell me a minimum price, that what you can afford unit wise. 10 unit PDF if I am providing you, what is your preferable price per unit? Per unit, what is your preferable price? You can suggest me the preferable price and I will put that price only. But you can do preferable price, so that you all can take it. Your preferable price, whatever. It is a printable version, you will get the printable version also. So unit wise PDF, concept with question, like that. Tell me your whatever you can afford for per unit, what should be the cost. You can suggest me. No, it's not my demand. I am telling you, it's not my demand. It's not my demand. According to you, what you can afford, that is only. If it is a printable version, what you can afford. So maybe what you can afford per unit cost. You can tell me whatever. No need to hesitate. Whatever you want, you can. As per your suggestion only I will do. And it is my request to everyone, please be ethical. You are buying PDF, you are sharing with everyone. Please don't do that. It is my request. Please don't do that. Let them also pay something, because whenever you are sharing with everyone, they are not paying, they will not learn. If they are paying little bit, there will be the value of cost, and value of my effort also, and they will learn. Okay, if you are sharing with everyone, then they will not learn. It is the thing. If you are paying the money, it's yours. It's yours. Okay, so those who are required, let them play. When they will pay, then only they will learn. If they are not paying, they are getting free, then they will not learn. Okay, USD dollar I am not asking. I am asking about there are some students are telling 9900, 9989, 599, it's too much. 150, 100 per unit, that is 1000. Achha, everyone is mostly telling about 100, so per unit. Achha, I will make it 99 as everyone is doing. Achha, then okay. So everyone is doing like that. 299. That is, maybe I cannot understand that 99 and 199. What is that? Okay, so I will make it 99. It's okay. So that is final. So everyone is telling that 99. Okay, I will make it 99, and maybe on Ganesh Chaturthi I will start selling. On Ganesh Chaturthi, maybe I will start selling. I am telling you, I am very open to everyone. Those who require PDF, today's PDF I will upload free of cost. That is free only. Today I will upload today's concept and all. I will upload free. But complete unit wise PDF, those who require, for them I will upload it. I will upload it with 99. Okay, I think that you can all afford. 99. ठीक है? Yes. Okay. चलो everyone, चलो. Bye everyone. See you again at evening. Evening we will meet again. Evening there will be surprise. Evening maybe you can get a surprise. Okay. Bye. Okay. Chalo, bye everyone. Bye. I will add the question in PDF also, definitely. In my PDF you will get concept with question. That is definitely. In my PDF is always concept with question. Definitely. And with PYQS also. With unit wise PYQS also you will get. ठीक है? चलो, bye. Have a good day ahead. Bye.